Auzu billahi minashaitanirrajim. Bismillahirrahmanirrahim. Dear students, today question number 1 and question number 2 of exercise. We have already attempted these two questions today. Question number 3 reads, in the adjoining figure, if LM is parallel CB and LN is parallel CD, prove that AM divided by AB is equal to AN divided by AD. Figure is like this. This is a triangle ABC and this LM is parallel to BC, and another triangle is here like this, and this is LN. This is parallel to CD. Now we have to prove that AM divided by AB, this is equal to AN divided by AD. This is to be proved. Now let us take this triangle ABC. We know by Thales theorem or basic proportionality theorem, if a line is drawn parallel to one of the sides of a triangle, then other two sides are divided in the same ratio. Therefore, in triangle ABC, this LM is parallel BC. Therefore, AM divided by MB is equivalent AL divided by LC. Name this equation first by BPT, by basic proportionality theorem, because we know by basic proportionality theorem, if a line is drawn parallel to one of the sides of a triangle, then other two sides are divided in the same ratio. Similarly, in triangle ADC, this LN is parallel CD. Therefore, AN divided by ND is equal to AL divided by LC. Name this equation second by BPT. Now let us compare these two equations. From equation first and from equation first and second we get. Now see, the right hand sides are equal. Right? What is the right hand side of this equation? Is AL divided by LC. And for this equation number 2, again it's AL divided by LC. So right hand sides are equal. When right hand sides are equal, left hand sides are also equal. So from first and second equation we get AM divided by MB is equivalent AL divided by LC. Sorry, is equivalent AN divided by ND. Now, adding 1 to both sides. What do we get? This is AM divided by MB plus 1 is equivalent AN divided by ND plus 1. So by cross, this AM plus MB divided by MB divided by MB is equivalent AN plus ND divided by ND. What is this? ND. AN divided by ND. Okay. ND. AM divided by MB. ND. Now AM plus MB is AB. This AB divided by MB is equal to AN plus ND is AD divided by ND, or we can write here AMB divided by AB is equivalent to ND divided by AD, taking reciprocals, or you can write here AM divided by AB is equivalent AN divided by AD. This was to be proved. So this was question number 3. Now question number 4 reads, question number 4 is like this. This is a triangle. ABC is a triangle, and this DE is parallel. DE is parallel to AC. Also, it's like this. This DE is parallel. DE is parallel to this, and there is another line, TF parallel to AE. We have to prove that BF divided by FE is equal to BE divided by EC. BE divided by EC. Now let's take this triangle in triangle ABE. Now see, we take this triangle ABE. This time this DF is parallel to AE. Other two sides are divided in the same ratio, because we know if a line is drawn parallel by BPT, if a line is drawn parallel to one of the sides of a triangle, then other two sides are divided in the same ratio. In triangle ABE, yes, in triangle ABE, DF is parallel to AE. Therefore, BD divided by DA is equivalent to BF divided by FE. Name this equation first by BPT. Now let's join this line segment and take the whole triangle. In triangle now, in triangle ABC, this time this DE is parallel AC. Therefore, BD divided by DA is equal to BE divided by EC. Name this equation second by BPT, by Thales theorem. Now comparison karo. Let's compare these two equations, equation first and equation second. Left hand sides are equal, BD by DA, BD by DA. So left hand sides are equal, right hand sides are also equal. From first and second, we get, what do we get? We get BF divided by FE is equivalent to BE divided by EC. This was to be proved. So this was question number 4. Now question number 5 reads, so simple. Question number 5 is, in the adjoining figure is like this. Now here it is a point. It is joined to this. This is PQR and this is EF. We have to prove that EF is parallel. EF is parallel to QR. This is to be proved. One thing is given that this EQ, here it is somewhere here, EQ is parallel to this point. Say this is O here. EQ. Now let's take this triangle. In triangle PQO, EQ is parallel to QO. Therefore, other two sides are divided in the same ratio. Therefore, PE divided by EQ is equivalent to PQ divided by QO. Name this equation first by BPT. Similarly, this is joined here and like this. This QF is this time parallel. Now let us take triangle POR. In triangle POR, this QF is parallel to OR. Now, when QF is parallel to OR, therefore other two sides are divided in the same ratio. Therefore, PF divided by FR is equivalent to PQ divided by QO. Name this equation second by BPT. Now when we compare these two equations, again right hand sides are equal, left hand sides are also equal. From first and second we get, what do we get? PE divided by EQ is equivalent PF divided by FR. Now see, what we have proved is this PF divided by EQ is equivalent to PF divided by FR. PE divided by EQ is equal to PF divided by FR. So by the converse of BPT, when other two sides are divided in the same ratio, the line is parallel to the third side. Therefore, EF is parallel to QR by converse of BPT. So that is it. Inshallah, tomorrow we shall discuss question number 6 onwards. Till then,